get the show on the road here. I think we'll have around a couple hundred people on the call. And so we've had a great interest in this webinar. We'll be talking more about the clear aligners space and how it's transforming. So I'll jump out of this. As you see this video, for those, you'll see it again. You'll see the direct print clear aligner platform that we've created, that LexCreo has created, and it has been in use for some time now. And show you some of the exciting news that we haven't shared publicly yet. All right, welcome. My name is Michael Strohecker. I'm co-founder of LexCreo, also the Chief Revenue Officer for LexCreo. This is the directly 3D printed clear aligners versus thermoformed webinar. We were originally having this a few days earlier, but because of the typical work week, the dentists, orthodontists, and laboratories, everyone preferred to have this on Friday. I'm calling in from Pennsylvania. I'm at another conference at the same time, so bear with me if there's any hiccups along the way. But very excited to have this webinar and for everyone to hear really around LexCreo's philosophy around product development and digital dentistry, and also the embodiment of that for our direct 3D printed clear aligner, as well as hear from you about your questions about this system and how you can benefit and your patients can benefit from this. So as I mentioned, I'm Michael Strohecker, co-founder of LexCreo. We're based in Silicon Valley, funded by Kleiner Perkins, among other investors, and very excited to be helping the digital dentistry adoption and simplifying digital dentistry at the same time. We decided to enter the market if we can make a difference, and we feel we are. This is, as LexCreo, we have two businesses. One is the footwear business, where we have ASICS, Fila, Puma, Wolverine Worldwide, among other brands as our customer. And then our other focus is simplifying digital dentistry with clear dental appliances. We feel we're the leader, global leader in printing clear dental appliances, and you'll see more about that coming up. Okay, we're going to start off with a poll. So one of the great features of Zoom is to have a dialogue through polling with those who view, and this is your chance to answer the poll so that we can see, what people are doing and what challenges they're facing, what they like, they dislike in the market, and how they're operating at both at the clinic or laboratory level. We have dentists, orthodontists, and laboratories in this call, and all very curious about this direct print 3D printed solution, and also having some challenges in their operations that they would like to be addressed. So we're quickly getting people's feedback on these polls. We'll have a couple more throughout the talk, and so just take this as an opportunity to express what you're feeling and what you're thinking, and then also to see what others are. So that's the exciting part about this. So it looks like so the question is, services and products do you currently outsource? And thermoformed aligners is number one, braces is number two, tied with dental crowns and bridges, dental implants. So that's very clear that thermoformed aligners is by the majority on here are outsourcing to a service, be it a laboratory or a brand. So we'll go to the next slide here. So as far as the agenda is, we want to cover a lot. This is an hour-long talk, and there's a lot to cover. We'll quickly go through about LexCreo, get into the workflow and comparisons between directly 3D printing versus the thermoform process. We'll talk about some of the new challenges and invention that LexCreo had to do to create this solution. and then the effectiveness and cost. So this is we'll get into some of the technical. My background is I'm a mechanical engineer and material scientist by trade and education, but this is not a deep dive into the technical part of this. You'll see a lot. There is a lot. But we'll have more webinars and also other meetings. You can reach out to us directly to learn more specifics. But there is a lot of meat to this presentation, so we'll bear with me. There's probably more detail than we can cover, but happy to do that offline or in another session. Okay. Start off with about Lux Creo. We stood up the business in 2019. There was some technology development predating 2019, so as early as 2016. But in the midst of all the work that we've been doing, to basically 99% R&D, and that's maybe why some of you haven't heard of us. We've been heads down, really working hard to invent solutions that solve problems that haven't been solved in the market. We're tracking to about 250 patents so far. And counting. Our approach and philosophy to development, it comes from actually, there's 4 founders, including myself, and we have a systems approach to solving problems. And we really wanted to use some off-the-shelf products, but we couldn't. They just didn't meet the need that we were solving, like direct print clear aligners, getting FDA Class 2, improving this and simplifying the manufacturing process. And really, our philosophy is that you have to control the software, the hardware, and the resin, and the whole process in order to deliver something unique in the market. It may not last for more than a few years, but this is where the state of the art right now. And it's very difficult to ensure safety, accuracy, and efficacy when you're just focused on, say, resin or just a printer or just the software. It all has to be tuned together to deliver these inventions that we've come up with. We have started in the digital dentistry world. We started in laboratories, so we have customers like Glidewell and Specialty Appliances. We're really happy with the volume that they're doing on our platform 24/7. These are larger printers and more like a refrigerator-sized printers. For example, one of our printers produces 300 to 400 splints per day. And we've been able to harden our systems, both in our factory for footwear, as well as in the laboratories, that some of these leading laboratories that push the limits of our technology. And so we've hardened our systems there. And then we've now packaged it up in a desktop form that leverages all the capabilities of the industrial printer. We can talk about the evolution of moving teeth. As you look at braces in the 1700s, and that we've made a lot of progress as the human race is looking to be more and more effective in straightening teeth and having that great smile. There's been various capabilities and limitations in technology along the way, but through invention and creativity, there have been amazing breakthroughs. And you start with various forms of braces, and then you have Invisalign and other companies doing the clear aligner with thermoform material. It's a big advancement in convenience. And then the materials like our DCA material, which is Class 2 FDA approved, to take it to the next level of convenience and efficacy. So what we'll see more and deep dive into how this is possible. Number one, when we brought this solution to the clinic level, either dentist office or orthodontic office, number one was it had to fit. It couldn't be a large refrigerator that you roll in there with some industrial equipment. It had to fit. And where you see Invisalign spending and investing a lot of money to create this automated factory in far off lands, you can now do it on your counter with 40 inches of space. And you can see the pieces of equipment and the software here. There's been questions in the past, are you a closed system? I think for direct print clear aligner, yes, because it's the only way to ensure safety and efficacy and accuracy. But when you look at all the other applications that you would want to do with this printer, since it's there and handy, you can do those. So we have partnered with Keystone and Dreva and other resin providers, industry leaders, to fill the whole portfolio. So it's very, very exciting about this. And so you don't have to think of this as a single purpose solution. It does all of the applications that you want to do. The business model innovation that we felt was necessary for doing direct print clear aligners is working with what people like to do today, or like parts of it, and maybe not all of it. And so when you look at it, when you outsource, which it sounds like 77% of the attendees are outsourcing their aligners to either a brand or a laboratory, when you have a solution like ours, you can do same-day service in 2 to 3 hour turnaround. You can go from scan to aligners in the mouth. And this is something that we are actively improving. And just in the last 6 months, we went from 6 aligners in 1 hour of printing to 16. And it's a tremendous effort on our engineering and clinical side to ensure that we can deliver safety, accuracy, and efficacy while also compressing the time. But we do not feel, and this is another philosophy around Lux Creo, we do not feel that the clinic should be a factory 100%. This is a partnership with laboratories and brands to where you can have do what makes sense same day and then outsource the rest. So the flexibility in the platform we've already built in. So laboratories that are using our solution, they can print. Laboratories like ODL are already doing this with us. And so there'll be more partners to expand this globally. But you can do 2 or 3 hour turnaround, give 2 to 3 stages to your patient, and then outsource the rest if you like, or fit it in with your work day, whatever time you have and labor availability. So we'll go to the next poll. Let's see what people say here. What is the most significant challenge you face with your current aligner offering? Give everybody a few seconds here to respond, and I'll tune what I'm covering based on this. It's not appropriate in a webinar for me to ask questions of people since I'm the only one that can speak, but normally in a meeting, I'd like to know where everybody is and how things are going. So if you feel like expressing yourself in the chat, it'd be great. Also, if you have questions along the way, please place them in the chat, and Finn will be fielding those questions at the end of the talk. So we'll leave room for Q&A. This session is planned for 1 hour. Q&A may go a little bit longer. So for those who want to stay during that session, are happy to. Otherwise, we'll make sure that we have all the great content that we'll be talking about covered in less than an hour. Okay, so we look at, it looks like too much labor required is the key challenge to aligner offering. So I think that you're going to resonate. Those who say that is their highest challenge or most important challenge, you'll see how we've addressed it in coming slides here. Let me move the results out of the way. Okay, so let's get into the workflow. And those of you who do thermoforming yourself or outsource it, this is the typical workflow. The only difference is that the large locations like Invisalign Factory, they put some robotics in there and it decreased the amount of labor, but it takes a lot of capital investment. And they did that, and they do it very well. So a typical process is scanned and to treatment plan, to the model generation, and then the printing of the model, post-processing of the model, blocking it out either digitally or manually, and you thermoform, and then you either manually cut it or you use a CNC mill for those of you who have invested in those CNC mills, and then you do the buffing on the edge. So that's the typical thermoform workflow. And the big difference here is now you don't need to create those models. And even before we got Class 2 FDA, we were the first to get it. This was May 2022. And we did not market it as we had it back then because we were still working on the solution to make it simple. We were working with some partners to move teeth, but as far as offering a solution, we chose to launch it a year later. So I think that might be a little bit more into the window of Lux Creo. We are not rushing things to market. We are more stepped in our approach to delivering value. So when you're looking at the process here, you have scan, then the treatment plan. That's normal. But then what most treatment plans have been doing is exporting these dental models that you thermoformat. They don't actually export a clear aligner. We were the first to create a clear aligner software called Lux Design. It was 3 years before we got FDA. We began to do this. What makes Lux Creo a little bit different than any other 3D printing company is we have a dedicated dental software team with dedicated tens of years of experience to deliver this product. It's not that we have some other kind of industry experience. We actually have decades of dental experience to create software for the digital transformation. So you take those models from the treatment plan, bring them into Lux Design. Lux Design within 3 to 4 minutes helps you automatically create the aligners throughout the treatment plan. When they go to print, they are automatically oriented, batched, and supported. There's no work to do. And then you go into the post-processing with 3D printing workflow. You do the cure, the wash and cure, and then trim. We have done some great work on inventing, but I'll get into that in a second. We have, as I mentioned before, the flexibility in the business model. So even though you have some same-day work that you want to do, or maybe you complete some of your patients' aligners, you produce them all yourself. As you're growing and differentiating in the market and you're growing your business, you may not have enough time. So this is an example of how you can outsource, and it's seamless. It's all on the same platform. Whatever you produce, the laboratory can produce equally, and vice versa. So you can have the flexibility of doing it yourself or outsourcing any of the stages at any time. As I mentioned before, Lux Creo had to invent many things along the way in order to deliver this solution and get FDA Class 2 for this solution and for the resin. So we have DCA, which is our dental clear aligner resin. We had that in parallel. We were developing the Lux Design software, and we committed to developing the Lux Design software at the same time as the material. I think it might have been around 4 years or 5 years ago. We also said that we had to solve the polishing. So when people talk about the labor, when you're printing aligners, maybe there will be other materials that come out that are effective at moving teeth, but there's really not an opportunity unless they print clear. So you have to be able to print clear, and this is washed, fully washed, and not leaving resin on it, causing potential accuracy and health risks. This is fully washed aligners that are clear. So we call that digital polishing. We had to invent that in order to make the workflow simple and very low labor. In further automating the process, we invented and created the iLux Wash Pro, and we have the Lux Cure Dental. So we have the automated wash and the automated cure. So when you think about us, think one-click print, one-click wash, one-click cure. And then the economics, when I mentioned that we went from 6 to 16, we also reduced the support structure necessary by 60%. So we went from $4 to $5 to $2 to $3 in a liner. That's the economics on the resin side. We got Class 2 FDA. We're the first to do that. And I know many businesses have tried to do this, and it's been a challenge for everyone in the industry, but we were able to crack that nut and be able to deliver this. We have a factory that is ISO 13485 certified, so that's a great thing. We understand all of the requirements around that. And then, like I mentioned, we didn't really commercialize until 2023, but internally we were working with our partners since 2022. Here we have the digital aligner, and what you're watching is the workflow in our Lux Design software. You can bring in a scan, or you can bring in all of the models. You can go with a scan, you can go directly to a retainer. It's very easy. And you can decide the thickness just with a slider. There's really not much to do at all. But when you bring in the aligners, you can bring in all of the models at once and work your way through the treatment plan. There we have machine learning that will help you along the way, as a lot of it is automatic. But one of the killer capabilities with direct print that it has from a design point of view over thermoforming is we don't have a sheet of plastic to work with. We actually can put material exactly where we want it. So that means that we can do single thickness, we can do single thickness, what we call gradient thickness with occlusal thinning. And then we also have multi-thickness. So we also have another machine learning capability that will analyze the entire treatment plan and place a little bit of extra material exactly where it needs to be to either grip the tooth or push the tooth in a direction, or tilt the tooth in a direction that you want it more efficiently. I mentioned that the clarity is something that is absolutely important for clear aligners. They're supposed to be clear. Now, when you see here the fuzzy one, the frosted one, that's what comes off of every other printer out there. And that compared to what comes off Lux Creo's printer, it's generating a tremendous amount of revenue for our customers while not having to increase their workforce. So we're seeing that laboratories are increasing their labor, or not increasing their labor, but increasing their revenue by 3x. And the clarity is 80% or higher, more than what's out there. Then we also are reducing the polishing time, at least 75%, as high as 90%. It's a truly amazing invention by Lux Creo to be able to say that dirty little secret of polishing after printing, we virtually eliminate it. The material development took many, many years and refinements on the material, and we were able to do all of these tests and pass, and by a lot of margin. So this is not just a barely passing resin. This is a leading resin using all of the internal capability we had of our material science team to be able to not only digitally polish it, it had to be tuned for that, but also to perform and move teeth in the environment of your mouth. This, as everyone knows in the industry, is a huge challenge to develop this material, not only to be performing, but also to be manufactured in a simple way. Is this another poll, Finn?
There's a poll after this.
Okay, all right. So okay, so here's, we're transitioning to how or if are directly 3D printed aligners better than thermoforming, and we'll see how we characterize this. So here's the poll. Let's hear what everybody has to say. So what is the primary concern you have when considering the transition to 3D printed aligners? I think this was one of my favorite polls as we were looking at all the polls that we wanted to collaborate with you on. Looks like accuracy is leading the race here. We also have cost and questions around safety and durability. Okay, great questions. All right, so we'll hit those for sure. All right, so I think in terms of the information that you'll hear today, you're going to hear some things that are a little bit counter to the current paradigm of thinking around ortho versus a restorative model accuracy requirements. You're going to see that what our findings are, and so the first question is, does accuracy matter? And I think what you'll find here is it actually matters more than the industry thought. It's not when we do dental models, for example, for laboratories or for clinics, our dental model material is material used for restorative models. Even though it might be an ortho application, our accuracy is unmatched. And then our ability to make it simple is unmatched. So when you look at it, accuracy is super important to Lux Creo in anything that we do, and you'll see why. Okay, this information is we actually didn't know how inaccurate thermoforming was until we did a lot of studies here. So I'll walk you through what's going on here, but the high level value here is that direct print is more accurate than thermoforming. It just is by a mile, Okay. Now I wouldn't say that all direct print 3D printed aligners are accurate, but at least our approach is very accurate, and we prefer to go for the highest accuracy we could, and to ensure that we can move teeth and also fit well. So what I'll talk through here is the thermoforming. So when you look at thermoforming, the scan shows 49%, right? Plus or minus 0.1 millimeters, and 81% 0.2 millimeters. Where you look at Lux Creo direct print is 75% within 0.1 and 96% within 0.2. Everyone's talked about ortho is only requiring 0.2, whereas restorative is 0.1 or even 0.05. Okay, these are scans, so it's looking at the surface that's within these margins and giving you a percent of the surface that's within the margin. So that's where the numbers come from. But from a thermoforming point of view, you have two inaccuracies happening. First is the dental model, and traditionally, everyone has said that just print the models on anything. You could print it on any type of printer. It doesn't matter. Accuracy doesn't matter. You want to go for speed. So most solutions out there or printers out there have sacrificed accuracy to get more speed. They go with a 100 or even 170 millimeter layer thickness. The printers themselves don't have much uniformity across the build area, so which affects accuracy. The resins themselves have high shrinkage or have other limitations in order to maintain accuracy. So a lot of inaccuracy in the ortho world for models. So that's where you start from. And then you go to thermoforming. Thermoforming over a model also has its own inaccuracies. It is really, you're sucking down a hot piece of plastic over the model. In that type of manufacturing process, there's spring back. There's the inability to take a sharp corner like an attachments on the teeth. So it's very difficult for a thermoform to grab that attachment. So when you look at accuracy, you really want to have the most accurate you can get. And I think that because of speed or thinking that there's no other alternative to the accuracy that ortho and ortho models have, that's been the industry standard, and that can lead to revisions or other complications and challenges within a aligner treatment plan. So what we're finding is that the more accurate you are, the more efficient you are with your forces. The more accurate you are, the better you can grab the teeth or grab the attachment. So the accuracy from Lux Creo's point of view is paramount to having an effective treatment plan and have to minimize the number of revisions or eliminate revisions. We feel that this is just the beginning, and you'll see that with all the flexibility that you can do with 3D printing, there's even more things you can do with aligners. But this is the accuracy comparison. And we're happy to have offline discussions or technical deep dives with anybody who would like to. So you feel free to reach out to us at any time. This is a study that was done with the university where they were comparing thermoforming thicknesses to direct print. So we did a series of treatments and manufacturing, and you can see that with direct print, you can control the thickness very, very well. And we have single thickness, like I said, gradient thickness, occlusal thinning, so you can improve the bite, but still maintain the thickness everywhere else. And then you can do a full free-form multi-thickness using our machine learning. But when you look at single thickness, we're doing single thickness everywhere. This is very challenging, actually, to be able to print and have your thickness be consistent time and time again. Now, when you look at other methods of printing and where you do the dental model and the thermoform, you see that there's thinning. It's a stretching of the material. And so the forces that you want to apply are weaker in those areas and can limit the addressable stages and cases. And it leads again to more revisions. When you look at the cost, I think everyone who's on here who does the outsourcing knows their cost. So these are some representative numbers. They could be up or down depending on who you are and your volume and where you're located in the world, because we have people from all over the world on this call. So I'd say the best way to look at this is a snapshot, a data point for you to see. But you can see that when you look at the blue, that's outsourced. And those are some fees that you would expect when you outsource your aligner manufacturing. You can look at traditional, which is thermoforming locally. Now, these are costs based on material and labor, and we can again do deep dives on this. But when you're looking at those costs, there's some equipment that you need to buy more if you don't want to have your team using scissors to cut your aligners, and you want to use the CNC mill. Now you need to buy a CNC mill and add it to your countertop space if you have it. So there's other ways to affect the numbers here. But when you look at our resin cost, we're in the $2 to $3 per aligner resin. And our workflow is about minimizing your active labor. So it can be doing the work in the back room while you're focusing on the chair and your patient. That is the whole motivation for us to develop this solution, is to minimize the manufacturing hours, the active labor hours. So we watch active labor like a hawk and allow you to do your business as you plan, but have that extra capability of doing same day. So what's new, this is something that I think anybody who's met with us at the various conferences at AAO or other conferences we've done with partners like Glidewell, and we have other resellers across the US and across the globe that are actively engaging with their customers. The first thing they do is they say, hey, is your material tough? And or is it going to break in your hand like maybe some other materials in the market do? Our material's very tough, and it's so tough that we allow the support structures to go all the way through the process, and you just rip them off at the end if you saw the video. But it's very tough and durable, and so that took a lot of work. We have to do some very amazing. I give kudos to our material science team that came up with this material. It was many years of iterations and improvements to meet that toughness requirement and still move the teeth in the mouth. So when you look at design, the one-click design, we're really a big fan of one-click. So it's one-click design, one-click print, one-click wash, one-click cure. It's the workflow can be that easy. And so what you're looking at here is the ability to do blocking. There's a lot of capabilities you would expect with other software in the market, like 3Shape and others, treatment planning software. You can do all of that in our software. The treatment planning software itself currently is not built into our software, but in Q4 it will be seamlessly integrated. So you can do treatment plan as well as directly exporting the clear aligner. So we have people doing this, and it's going very well. The one click for localized thickening, machine learning will do it for you. You don't have to think about that. It's around creating more efficiencies while also maintaining comfort. So all of this with the machine learning and the data that we've developed on this, it really is a one-click process. The expanded treatment options are also a phenomenal way to think about 3D printing aligners, where we have partners and customers printing hooks directly on the aligner so that they can do jaw manipulation or treat other cases that you wouldn't be able to with aligners. And we feel that directly 3D printing clear aligners is a way that aligners will expand their application base. So it's been 80% of the market has been braces, 20% of the market has been aligners. But we see a future where the aligner percentage of the total patient base will be more, maybe 25%, maybe even 30%. You can do precise pressure points and do unique ways of tipping the teeth. So it's a really a blank slate on your creativity and your experience applied to this design space. I'm going to show a patient here. This was not to be a deep dive on the clinical work that we've been doing, but I'll give you an example. This is the setup for a patient, a female, 23 years old. Our partner D-Cube has shared this information with us, and we're really proud with the performance. This is a 0.6 millimeter uniform. So this is not taking advantage of our localized thickening or any other types of optimization. This was just straight 0.6 millimeter aligners. And they've done, this woman has done 10 out of 15 steps, 0 revisions. She's following plan perfectly. So you can see the teeth where she started on day 0. And you can see that especially the lower teeth here. And then how they've progressed over 10 movements. And this was done same day delivery. This was done seamlessly. I think she might have lost an aligner and it was printed same day and she's right back into plan. It's just so easy and with very limited labor to do this. So not only was the delivery and manufacturing of this very simple, but the patient really enjoyed the experience and is enjoying the experience. She has not had to come in for a revision, and we're looking to that success continuing through the next 5 stages. It's like, how is that possible? So there's been many attempts to create this material, aligner material by others, and they have fallen short on stress relaxation in a warm, wet environment. They've fallen short on this is getting a little bit technical, so maybe some of you just hold on for a second. but the glass transition temperature is a temperature of when, and it's not a cutoff. It does start earlier, but is when the material starts to soften. Okay, so our glass transition temperature is close to 120 Celsius or 116 Celsius. And other materials have been much lower than that, which means that once you put it in your mouth, it starts to soften. And when it softens, it relaxes. And when it relaxes, it doesn't apply forces. So we designed, and this is key design criteria for our material, and besides tensile strength and other mechanical properties, we just couldn't have it soften in your mouth to a point where it wouldn't apply forces. Now, a lot of materials soften in your mouth. So you can see curves here where you soften, but you have to stay over this magic line here. The other part of this, which is a key benefit between the direct print aligner versus a thermoform, is that a thermoform material is a thermoplastic. So what thermoplastic means is you can heat it up and stretch it over your teeth, and it's necessary to create an aligner. But what thermoset means, it's what we do. We print a liner with a thermoset acrylic. And what that means is it's cross-linked. And what cross-linking means is you have these polymer chains crossing and linking and creating these amazing material properties. And what that also means is that once it is cross-linked and is in the accurate shape, if it goes out of shape, there is a way to bring it back. And because our glass transition temperature is so high by design, we wanted to deliver an aligner that has never been in the market, which means you can disinfect and bring your product back to, so the appliance back to perfect accuracy, 99.8% here in the bottom right corner, just by turning on your tea kettle and boiling it at 100 degrees Celsius and then pouring it onto the aligner. You would never do this with a thermoform. It would turn to mush, right? But ours goes back to perfect shape. And not only does it go back to perfect shape, so you can disinfect it with, it's a first aligner you can disinfect with hot water, and that the patients love this. They just, I just pour hot water on it and it's clean and ready to go again, not gunky. I don't want to put the chemicals on it to do that or brush it with a toothbrush and toothpaste. What happens is every time you do the hot water, its stress relaxation is even less. So it just keeps performing better. It goes back to accurate. So you take it in and out, you take a thermoform aligner in and out of your mouth, and that will deform. and be less and less efficient. So you have accuracy going against thermoforming. Now you're taking it in and out of your mouth, and that's weakening or opening it up a little bit, so its accuracy is even worse. With the direct print, you can print it more accurately, so you produce it more accurately, and then every time they disinfect it with hot water, it goes right back to shape. This has never been done before. And again, if you have questions, please post them so that Finn can field them at the Q&A. Here's an example of what we discussed. Tea kettle, hot water, boil the water, put it into a container like this or your coffee cup or something like that. And you put our material in first. So this is a DCA aligner printed. On the right, you have the Thermoform, one of the leading thermoform aligners. You take it, you put it into the hot water, it immediately goes back to shape, and you leave it in for a few seconds, and now you disinfected it, ready to go again, fresh, just like it was just delivered to you. And you look at the result. It's perfectly back to shape. So we've done this many, many times, and scanning data proves that we get around 99 to 99.8% accuracy. Now you put the thermoform in, and we know that because it's a thermoplastic, this is just not fair. The thermoforming is not able to do this. That's why you have to use chemicals, or you have to use a toothbrush and toothpaste, which also affects the clarity. Now it may look like it's shaped, but it's never going back on your mouth. The molars are compressed. It would never go and never fit again. So that's why I say don't drink it with thermoform in your mouth. Don't drink it with hot water. You can see the performance, the durability, all the capabilities of our material, or you can see how it's all compressed there in the molar. It's just never going to work again. Even if you cram that back on your mouth, it's more of a cover than it is a mover. So when you look at our direct print, it's all back to shape and ready to go again. Okay. So in summary, I want to just, and we're going to go into Q&A, but in summary, I wanted to cover, remind everyone what our goals were here and our ability to help patients and clinics and laboratories. So from a patient point of view, you're looking at faster start. So the patient can come in, get scanned, and get that first aligner in their mouth that same day, which is really amazing experience for the patients. The clinics love delivering that kind of value as well, laboratories as well, for their turnaround and efficiency. And then you look at easier to clean, like I mentioned, you can put it in 100 degrees Celsius, it will disinfect it and bring it back to shape, so you get a double whammy of value. And then fewer revisions. And right now we're seeing fewer revisions because of the accuracy and the material's ability to perform. So you look at the benefits to the clinical laboratories, you're looking at better patient satisfaction. The patient can easily clean it, like we saw, and get started faster. And if they lose one, they can print it immediately and get back into plan. You look at more accurate aligners. They don't also have to do the dental model anymore, so they can eliminate that part of the workflow. There's automation coming for the laboratories and at scale for early next year that will eliminate the majority, if not all, the labor to do that. And so we're very excited about bringing that next year. But more accuracy is really welcome. And then the expanded application base. And so what you're looking at, both clinics and laboratories may have shied away from doing the aligner business. Maybe they thought they couldn't compete with Invisalign or others. And so now with very little labor, very low active labor, very little material, and a workflow that prints in an hour 16 aligners, you can see how this could ramp up for laboratories and clinics to where they can do it themselves and feel confident that they compete in the world, delivering very efficiently, very cost effectively, and in a differentiated product. So a couple things about Lex Creo. We are expanding rapidly. So we just closed close to basically downtown Chicago. We're opening a training center, so for CE credits and to learn more about this direct print clear aligner. We do not have that set yet with the clear aligner CE credits yet, but we're working on that. But we are a purpose-built training facility, support 6,000 square feet to start. in the greater Chicago area. It's less than 20 minutes from either airport in Chicago. And you can see a list of some of the people that we want to hire and make part of the Lux Creo team. We're very excited about this expansion, and we will still be in California, headquartered in Silicon Valley. But then, as Lux Creo, we have a very fast acceleration of the business, both here in the U.S. and in Europe. So when you're looking at the rest of the Q&A, we'll stop here and let Finn field some of the Q&A questions.
Yeah, thank you, Michael. Nice job, and we're doing great on timing, and we have quite a few people left here. So thank you everyone who stuck with us. So we'll have quite a few questions, so I'll just start getting to them. So one of the first ones is around the Lux Design software. Two-part question: do you use any planning software in the market? And is the Lux Creo software exclusive? Does it integrate with any other software?
Okay. So there are a lot of good questions in that. So I would say that the Lux Creo Lux Design software is a standalone product. So we feel that this is a very seamless way for our customers to use our solution, but we also feel that there's a big gap in the market for creating direct print aligners. So this Lux Design software will be available in Q4, so just another month, as a standalone product, where anyone, even if you don't have our solution, can use the software, and then you can access manufacturing base that we have with laboratory partners to do the production for you. You can have some quick wins there, and then justify purchasing a solution as well. So that's one part of it. As far as treatment planning software goes, we really don't care which treatment planning software you use, as long as they can export the dental models, then it can be imported into Lux Design. You can be on your way. We do have one or two different aligner treatment planning software that we're going to integrate seamlessly with Lux Design. So within Lux Design, you will have that treatment planning capability. It's not our software. This was the first time that we're bringing software integrated into our solution that we didn't create ourselves. We have integrated with Glidewell's fast print and fast design, but we have not integrated software into ours until this time. So we felt that going with some of the industry leaders in the dental space would benefit our patients, and customers would benefit from it. So in Q4, you will also have that ability to do treatment planning within Lux Design.
Awesome. Okay, here's a quick one for you. Do you have a supplier in the European Union?
Yes, we do. We have a couple. Like you saw D-Cube in Italy. We have iMaker in France and UK, and then we're growing. We'll have pretty much European covered by the end of the year.
We've got quite a few questions around the material properties of the DCM material and the curing wavelength. All this information can be found on the Lux Creo website, DCM material, and there's technical data sheets there, or you can contact us and we can send it.
Yeah, and I think that, like, one thing I'll say is that we really did want to buy equipment off the shelf and bundle it in. The challenge was that it wasn't enough to do the wash or the cure, so we had to develop it ourselves. And our cure is a dual wavelength, 385, 405, very high intensity. Was just not on the market. And the wash is an automatic wash where we have both IPA, full submersion, both agitation and ultrasound, and then we also have a Lux Fresh detergent where you don't have to have an IPA workflow. And then with that you can go to elevated temperature, so you can use all the capabilities of our iLux Wash dental solution. So I'd say that we're happy to do deep dives on technical aspects of the material and our solution and equipment. It's probably not appropriate for this call, but please contact us directly and we can do that.
Great. Okay, you kind of answered some of the two other questions. So one of the questions was around is nitrogen required and is IPA required in the post-processing of DCA?
Nitrogen is not required. I think the best way for those of you who've heard about nitrogen being used, a lot of times it's needed because of the uncured resin left on the aligner. And because we said that was absolutely not a way that we were going to support, because any inconsistency in following the statement of work and the process could lead to uncured resin going in the patient's mouth. So we absolutely did not want to make that even a possibility. So not only did we choose to wash thoroughly, but also we created the automatic wash so that you don't have to worry about variation between technicians or your employees. And so health and safety is our top priority. Nitrogen, say you have a perfectly clean aligner or any other appliance using nitrogen, that it can help with accelerating the time, but is not necessary.
Good. Couple of questions around attachments. Does the material work well with attachments? And if so, can these attachment templates also be printed with the same material, or is another material required?
Oh, great question. The beauty of printing with a material that's very capable, durable, tough, also capable to do its primary function is moving teeth. When you have all that, all those mechanical properties built in, you can print it right there with the same material at the same time. And we're able to do some things that a lot of printers cannot do, which is print without supports. So when you have a hook coming off the surface of the aligner, in a lot of printers, you might have to put support structure there and then remove it and then file it down and all that. We can print hooks and other types of features on the aligner without any supports. This is very challenging to do. We did this also in dental models where we can print vertical digital ditched molars with, and then next to a full pallet model, next to a CNC clipped aligner model, all unsupported overhangs, printed at 50 micron layers as fast as anybody does it in the world at 100 microns or even higher. So our learnings and capability on the model printing with unsupported overhangs enabled the aligner printing these features on the aligner.
That sounds like another webinar topic for us in the future. What is the average cost for printer, cure, washer, software bundle?
Okay, so the solution, so that's the printer. The printer is $15,000. The solution with the automatic wash and automatic cure is $20,000. So you think of $15,000, then $2,500 and $2,500. So that's the solution cost. And what that ends up being with the resin cost, the resin is on a per aligner basis, like I said, dropped from $4 to or $4 to $5 down to $2 to $3. That was mainly from using a lot less support material. So if you think of Lux Creo, we always go conservative to ensure accuracy and safety and efficacy, and then we refine from there. So we've got enough data now over the past year, to reduce the support structure by 60%. So we're 40% of the original support structure approach, and we went from 6 to 16 per build. So you got more per build and a lower cost per aligner.
Awesome. Are there any published papers regarding the geometrical accuracy and force levels of this material?
We have accuracy, like I showed, in that's with a university and a master's student who did this. And then on the force applied, I think we have some, but it's not published from. It's something we share with our customers, where we do have force data.
Cool. How can the trays be labeled? We laser mark our form trays.
Yeah, well, it's automatically done in Lux Design. You can have labels on the molar or any other place. It's 3D printed, and so you can see it clearly there. And that's an automatic workflow built into Lux Design. So that's something that we definitely heard from the market and the users And so that's very easy. It's 3D printed in, and it's like it's embossed. And then the laser, if you have a laser that you like to mark with, laser marking works perfectly fine with our material. And then we have in the new year, we're doing a laser cutting and laser marking for high volume applications. So it's all fine.
We got quite a few questions around the post-processing, just trying to learn some more information about what is the digital polishing, how much effort is needed for post-processing. So maybe you can just kind of go over that again of the different steps.
Sure. So the post-processing is so most companies develop a technology and then try to find a problem to solve. Lux Creo found the problem and then built the entire solution to solve it, and that was polishing. Polishing is, if you can't get rid of polishing, there's no way you can do direct print clear aligner. You're not going to spend 10, 15 minutes per aligner. If you have 20 stages, that's 40 aligners. There's no way you're going to spend that much time on it. You might as well outsource it. So we worked for years to solve polishing. And what that meant is that the surface of the aligner is printed clear. And everyone says that they print clear material, but this is clear after you wash and cure. Anything wet looks clear, but when it's dry, that's when you really can tell, and it has no resin on it. So the approach was solve polishing, develop the best in class aligner material to get Class 2 FDA, and then have a solution that is easy to use and prints accurately. So those are all the key criteria, which means our material scientists didn't, when we do a new resin development, it's not just the final performance, it's the whole workflow. Since we have a workflow mindset and a solution mindset, our scientists had to create material that could go through the post-processing steps without changing or distorting and changing shape or distorting based on that process. And in the printing, we had time gates that we had to print. We had to print in an hour or less, and we will print faster. We're at an hour right now. And even when we tilted it taller, we still maintain the hour so that we can get up to 16 in a batch. Now, when you're looking at all these, how does digital polishing work? We're able to do nanotexturing on the surface, which all polishing means is that you have a very smooth surface. We're able to do that printing at 100 microns or even 50 microns. It's clear. And our native resolution of the Ilex Pro Dental is 50 micron by 50 micron, yet we can control the nanotexture of the surface. It's never been done before, right? And this is a key capability and that we invented. And what it really comes down to is you have to be able to tune the material and the hardware and the software together. So you have to have control of those developments in order to deliver digital polishing. So when you do the workflow, all you do is you print, you wash, you cure, and then after you're done curing, the support structures are still on it. That's how you maintain the accuracy. And then you just pull it apart and then buff the edge. When you're looking at buffing the edge, it depends if it's scalloped or straight line. Of course, straight line is faster. You just do the edge and it takes a few seconds. But with scalping, depending on the scalping, it can take a minute or more. It could be a minute to 2 minutes per aligner, depending. But there's no different than what you would do with a thermoforming on the scalping, unless you have CNC mill. There could be a competition between who could do it faster, a CNC mill versus experienced technician on scalping. So maybe we'll post a video of that.
Good idea. Quite a few questions around, can you use this resin with any other printers on the market?
Yeah, the industry is not ready for that yet. From our point of view, our resin is higher viscosity, higher molecular weight, which means that's how you get the high performance. Lux Creo's mastered the high viscosity printing, consistently batch to batch, across the batch, machine to machine. We have many hundreds of printers printing for footwear as well as in dental. So you have to have consistency. But if you were to pour a resin into one of the other printers that doesn't have consistent heating, then you wouldn't be able to print very fast. You wouldn't have digital polishing. You may have a lot of accuracy problems. And those are things that we don't want to bring to market at this time. And we haven't seen a printer out there that could really print our resin well. So what we're doing is providing a solution and a service with our partners. And maybe eventually there will be a printer out there that could print as well. Or, but right now the best approach to ensure safety, accuracy, and efficacy is a controlled solution.
Perfect. Okay, so we're at the hour, so we'll try to do maybe 2 or 3 more questions. Couple of questions around the printing time. So what is the printing time for full plate at 50 micron layer height?
We're printing our aligners at 100 microns and have great accuracy. Those numbers that we showed on accuracy are 100 microns. And what we're doing is an hour. When we only had 6, you can think of the aligner was tilted a little more heavy supports on the edge. All the supports are just on the edge. None of them touch the surface. But when you have an aligner at this height or at this angle, it's a shorter height. Now you pitch it up a little more so you can get more of these aligners in side by side. We were still able to achieve an hour print time, even with up to 16 aligners. So the number of aligners in the batch do not affect the speed of the printing. It's really the height of the aligner that affects the printing speed, printing time.
Perfect. Couple of questions. How many aligners can you print in a full bottle of resin?
Oh, here, I think we're at 100.
Yeah,
I have to do a calculation
yeah,
real
maybe
quick.
we can send that out in the post email.
Yeah, like over 150.
Perfect. What about maintenance of the printer? What's required? What does that look like?
Yeah, that's a good question because the printer, there's never been a desktop printer built like this. So for number one, I probably should have led with that at the beginning, but our company has been 99% R&D and 1% marketing. So we'll do better on the marketing. But the printer itself is really a industrial printer masquerading as a desktop printer. It started off as 100 pounds. And now I think we're down to 70 or 75 pounds, but it has everything that we have in our industrial printer. So from a maintenance point of view, we're talking the membrane. So our LEAP technology, we patented so many different ways. That is we say it works for 50,000 or 50,000 layers. So you can look at the height divided by 0.1 millimeters, and that's how many layers you have. Our LuxFlow software will tell you how many layers you've done, but 50,000 layers in a clinic could be a month, and then in a laboratory printing 24/7, we're at 2 weeks easily for this. It could be a month as well. So, but we say 50,000 layers is good. It's very durable. We've done many years of improving the durability, so that's not a concern there. The other part of it is there could be depending if you're a clinic doing your work 1 shift or shift plus overnight versus doing a laboratory 24/7. There could be a calibration done on the light energy output, so that we run our light engines lower than max. So it takes a long time for them to change in intensity. But as they age over, say, a few years, you'll have to do an intensity calibration, but it's not hard. The system itself is super robust. It's all industrial components, and it's a beast as a printer. We have some laboratories saying that it is a mini industrial. It actually beats most of the industrial printers. The desktop printer does. So we may show some head-to-heads later, but you can easily do a couple hundred splints on iLux Pro Dental daily. It's really amazing machine.
Awesome. Okay, we'll finish with this one with a couple of questions asking what is the difference between this resin and graphics resin?
Oh, that's a good one. So I think Graphi's done a great job at bringing the attention to direct print aligner, even though we got our Class 2 FDA way before they did. I think their approach is different. We actually said no to certain technical pathways that they've adopted, and one of them being that they don't have digital polishing, so they have to leave resin on it. So they do some spinning, which leaves the possibility of resin, uncured resin, being a patient being exposed to uncured resin. Also, it can affect accuracy. The other part is their glass transition temperature is much lower, and so that means it softens in your mouth and can lead to force reduction and accuracy reduction, things like that. And then the material itself at room temperature is brittle compared to ours, so it's just a different technical approach to us.
Awesome. And so that wraps up the webinar. Just some housekeeping. This webinar recording will be sent out to everyone who registered on Monday. We'd also love to hear from you all about what you liked about it, what you didn't like, and some of the topics that you'd like us to cover in the future. And yeah, Mike, I'll let you close it out.
Yeah, I want to thank everyone for attending. Lux Creo is here to solve problems. I want you to leave that. It's our engineering mindset. It's our customer success mindset. We really want to help everyone advance digital dentistry. And we feel that a solution like ours will expand the application space. So this is a growing pie for everyone. I think that there's been some challenges, say, over the last couple decades of a pie not growing as fast as people would like. But I think that we can help everyone grow the pie and help more patients across the globe. So I hope that anyone who attended it would contact us directly or even on email, ask us questions. We're happy to do deep dives, happy to understand your business and your business challenges. We don't tell you we can solve anything until we listen. So we always start with listening. And please tell us how we can help. And based on what you learned here, any follow-up, we welcome.
Thank you, everyone. Have a good weekend.
Bye. Thank you, everyone.